Hello everyone. Today we are going to be talking about model fitting in R. We are not going to get into the nitty-gritty kind of theory of different models. We're just going to be talking about how we can fit them using the Broom package or using base R functions. So we're going to be talking a little bit about summarizing the model, doing a little bit of inference, and some prediction. I'm showing you two ways because the Broom package is nice because the output is a tibble, which is something that we're familiar with, but you can't use it for every single model that you make. There is a little bit of limitations for it, but for your basic kind of like linear models, GLMs, things like that, you should have no problem using it. But just in case it doesn't work, I'll also show you how to do it in base R, which is honestly the method that I learned. We will be going through an example with just a simple linear model. It's okay if you don't know all of the stats that I'm going to be talking about. Just take them at face value for now. The purpose of this video is literally just how we fit them in R and what functions we're going to be using. Let's get right into it and get coding. Let's start by loading in some of the packages that we need. So we're going to be using tidyverse and some data from the gapminder dataset. And I'll also be talking about some functions from the Broom package. And again, if you have not installed them already or you get some errors, you can use install.packages and run this line of code just once to load these packages, install them into your R environment. We are going to be looking at the mtcars dataset again and just visualizing and talking about the relationship between weight and fuel efficiency, so the miles per gallon. If you're unfamiliar with ggplot, I'd recommend going to look at that lecture before this one. I'll link it in the description. But for now, let's just look at a very simple scatter plot, looking at the relationship between weight of the car and the miles per gallon, or fuel efficiency. So what I've done here is I've used a scatter plot and I've added what we call a smooth line trend using geom_smooth. So I've used the LM method. That just means linear model. So I'm literally just plotting a line. It's the exact same as that y equals mx plus b thing that you learned in high school. SE equals false is just removing those confidence interval bands because we don't really need to talk about those right now. So just add that back in. If we look at this visualization, we can see that, yeah, it looks like there's a relationship between miles per gallon and the weight of the car. We see that there is a negative relationship as weight tends to increase, miles per gallon also tends to decrease. This visualization is very useful and it can actually inform our analysis. So after looking at this visualization, I could say, yes, I think that a linear model is appropriate, but I can't actually extract anything from these linear models directly from ggplot. So it's really useful to fit these models outside of ggplot, even after we've used a smoothing method like geom_smooth to visualize the relationship. So let's fit our first linear model in R. So typically when we fit a model, we have following format. So we have a method and it takes in a formula. That formula describes how all the covariates are related. We have a data, so it could be a tibble or a data frame containing your data. And then a number of options that are sort of specific to the method that you choose. Today, we're just going to look at the LM, linear model. To fit a linear model, we say LM, and we're going to write a formula that describes the relationship. So here, miles per gallon is our Y variable, our outcome of interest, and weight, WT, is our X variable, or our independent variable, or covariate, whatever you want to call it. The data that we are taking these values from is mtcars, and honestly, that's it for our linear model. So when I run that line of code, this is what gets printed. Actually, first, let's just save it as a object in R first. And so we get this printed. It tells us exactly what we ran, the model that we're fitting. And then we get two numbers here. We get the intercept, and that is literally, if you look at it on the graph, if you were to go, this is sort of 1 and 0 would be over here. You get an intercept around 37.285. And this WT minus 5.344 is actually the slope of the line. And if you're more familiar with linear regression, this is beta 0 estimate, and this is the estimate of. Now, this model actually contains so much more than what's just printed. This is sort of the minimum information that it prints, but we need to use functions to look at the other components of this model. So let's first do that using the Broom package. The first function we're going to look at is called tidy, and that's basically going to print out a nice statistical summary of some components of your model. So my underscore LM is that model that we fit, and I'm just calling the tidy function on it. And it's returning a tibble. So it's actually really easy to extract all the components of this tibble that's outputted. So we have one row for each component of the regression model that we ran. We have an intercept, and then we have a coefficient that would be in front of that weight variable. And we have their estimate standard error, and then we have these other two columns which represent a statistical test. Not going to go into the details, but it's basically testing whether or not these are 0. We also could use the augment function, and this is going to allow us to do prediction. So by default, if we just call augment on my underscore LM, it's just going to perform predictions on that data set as a whole. So let's look at the output here. We can see what the miles per gallon and the weight were in the data set. These are the actual numbers. And then we get a fitted value. So for that, it would say, okay, well, if I had a weight of 2.62, about here, what would the model spit out? So in actuality, it's about 21. But the model predicts, this blue line, 23.3. So that's the number that's coming here is, well, what is the model going to spit out? The residual is going to show the difference between those two numbers, telling us how good of a fit that is. And the other ones you can kind of explore on your own. I'm not going to get into them right now. So that's useful for kind of checking the fit of your model. But we can also predict new data using our model. So let's make a little tibble containing weights of cars, let's say 2, 3, and 4. Sure. And when we call this, it's going to say, okay, take this new tibble. I have weights of 2, 3, and 4. Based on that model that I fit, let's predict it. So for a car with a weight of 2, then our estimated miles per gallon, our fuel efficiency is 26.6, and so on and so forth for 3 and 4. Now we don't have all of this other information because we don't have cars in our data set that have these exact weights, so we have nothing to compare it to. But that's totally fine. The next function I want to show you is glance. And this is going to show you a little bit more information about your model than what's printed just by default. So we again have a tibble. It's very easy to extract these numbers. We get R squared and adjusted R squared values. These are measures of how well the model kind of summarizes the data. And R squared value equal to 1 is a perfect model fit, and closer to 0 is much, much worse. And then we have some other things that may be of interest when you're looking at your model. Now, as I said before, Broom is really nice because the output is a tibble. But Broom is a little bit limited because if you do more complex models than a linear model, there is a chance that nobody has really coded this into the Broom package. So sometimes we do need to rely on base R functions to get this information from our model. So I'll show you how to do that as well. So instead of using the tidy function, we can use summary. And that's basically just going to print out a bit more than what we saw in the tidy function, but it does give us some of the same information. So it's going to print out essentially a summary of the model. We have a similar table that was printed out with our estimates, our standard errors, and then some information on statistical tests. Then we have a bunch of more information, which is similar to what we saw in glance. So I would say summary is like glance plus tidy together. The annoying thing about base R is it's really hard to extract these numbers. But if you call names on that summary function, you can see what we can actually get from there. So let's say I wanted the R squared value, then I could do summary my underscore LM $ R dot squared, and it will output that R squared value. It's just a little bit less straightforward for getting this information than when we use Broom. But it's still very much useful, and this is honestly what I tend to use more. And we can also do prediction with base R, and that's just with the predict function. So we are going to put in the model that we fit, and just provide it some new data. And it can be in the form of a tibble as well. I think I used 2, 3, and 4 before. And a little bit less fancy of output, but it's going to output the predicted Y values. So here it's miles per gallon for weights of 2, 3, and 4. These are not the weights. These are just like the indexes of the table that is outputted. So it's a little bit less clear, which is why I actually do prefer Broom for prediction. So that is an example of when a linear model is appropriate. Let's look at another example where we might not have data that is summarized well by a linear relationship. I'm using data from the Gapminder dataset, and I'm just going to filter on only Zimbabwe. Let's take a look at what this data looks like when we just plot a simple scatter plot. Now, when I look at this, I may initially think, well, this is quite linear, very linear, but then something happens around the year 1992, and it causes the life expectancy to drop off. Here, a line of best fit may not fit the data well at all. So let's just add a linear regression line to our plot and see what happens. I don't think this describes the relationship very well, but again, we can't really get the information of how well the fit is other than just like a visual inspection. So let's also fit this model. Well, we just have to say, let's just call it Zimbabwe 1. And it's a linear model, and we are regressing. Our Y value is life expectancy. Our X value is year. And the data is Gapminder _ Zimbabwe. Let's make this a little bit bigger. Let's take a look at the output of this using Broom. Let's call the glance function. And we can see that we have a really low R² and adjusted R². So a great model has R² close to 1. This is close to 0. So this fit is just awful. So if that's not a great model fit, then maybe we should look into different transformations of our model. So we're still technically going to use a linear model, but I'm going to allow it to be a second-degree polynomial. Because if I look at just the scatter plot here, I think that a U shape is going to fit the data at least a little bit better than a line. So when we're using our plot, we're going to still add a smooth line with the linear model method, but I'm going to specify a formula. And I'm going to say, well, let's let Y be the same, but let's let X be a second-degree polynomial. A comma there. So it's not perfect. This blue line looks like it fits the data a little bit better. And we can quantify that. So let's fit that same model here. Let's call this the second Zimbabwe model. And let's regress it on a second-degree polynomial of year. And look at the output. Whoops, poly, not ploy. So now our adjusted R² and R² values are much better. They're between 0.6 and 0.7. That's fairly moderate, as opposed to before when it was hovering around 0. I would say that this model is a better fit. So again, we could visually assess that the model was a better fit, but by calling glance on that actual model object, we could quantify how good the fit was. And we can do that even better by using all the other ones as well, but I'm just mentioning the R² value for simplicity here. So I hope that was useful. I'm going to end it there, and it's really up to you whether you want to use base R or Broom functions, but I hope that you'll explore both and you learned something new today. See you next time.